In this video, which is titled How to Shaders, we'll learn how to approach creating some of the fundamental materials including plastic, parquet or wood generally, concrete and metal. Hey folks, welcome to MoGraph Plus. This video is a free sample from our course V-Ray 5 Masterclass, your complete guide to V-Ray for 3ds Max. It's a massive 15 plus hours course in which we explore all the aspects of V-Ray for 3ds Max thoroughly. Make sure to check it out. The link is in the description. Also be sure to subscribe and ring the bell to get notified about our latest videos. Let's start with plastics. I'm gonna open up the material editor, create a new fast SSS2 material, and assign it to the shader ball and run the IPR. The reason I don't use V-Ray material for plastic shaders and use fast SSS2 is the lack of a subsurface scattering component in the V-Ray material. And adding a simple subsurface scattering component to V-Ray material is one of the biggest improvements that Chaos Group can work on. How come V-Ray material does not have that yet, considering how much subsurface scattering is essential and can add to the realism of the shader? It is really strange they still haven't added it yet. I hope they'll look at Arnold's standard surface shader as an example and add a similar subsurface scattering component to V-Ray material as well. But we work with what we got. For plastic shaders, we don't need much diffuse contribution, but we might add a bit later on. First, we need to decide on the color of the plastic. We are going for a red plastic here, and normally you want to have the same diffuse and subsurface color. So I'm gonna add a new V-Ray color map. We can use the colors here, but I think the color map will help us if we want to change the color of the diffuse color and subsurface color at once. So in the V-Ray color map, change the color to this kind of vibrant red with the RGB values of 172, 7, and 7, and change the RGB color space to sRGB primaries as we are in ACES, and use it as both the diffuse color and the subsurface color. As we are dealing with plastic, let's change the Fresnel reflectivity or IOR to around 1.5, 1.55. If you have any issues understanding these parameters, you can refer back to the previous videos where we explain these parameters in detail. Now let's work on the scatter radius, and that really depends on the particular plastic that you want. Does it have a dominant look and feel of subsurface scattering or not? Then you can decide on the amount of scatter radius. In this case, let's try something around 3 centimeters, and that should be enough. Now, coming down to the specular section, I mentioned in the reflection lesson that for most materials and shaders, you can safely keep the specular amount and color at 1 and white to keep the shader as physically accurate as possible. In the past, we used to control specular or reflection amount and specular color and specular glossiness or reflection glossiness, and then define very specific IOR values for each shader. You can actually forget that. In this kind of new approach, specular amount or reflection amount and color is always 1 or white, and just specular color is just a simple white, or reflection color is just a simple white. It's called specular in the subsurface scattering material. And the IOR value for most daily shaders like plastic, wood, concrete, and so on can be around 1.5. The only thing we are interested is the specular glossiness or roughness. We add variations to the specular glossiness with a grayscale texture, and that adds all the realism we need. Let's add a V-Ray bitmap node and load this BW_metal texture. This will be used for specular glossiness, which is a data input, and as we are in ACES, let's change the RGB color space to raw. And also, if you have any question about ACES, check out the video in the introduction section and the video in the rendering section of the course about ACES. Also, we'll be using this map later on for bump mapping, so I'm gonna keep this original version unchanged to be able to adjust its black and white values and therefore control how exactly specular glossiness looks eventually. Let's connect this texture to an output map and connect that output map to the specular glossiness input. If we look at this texture as it is connected to the specular glossiness, the brighter pixels will end up making the specular reflections look sharp, and the darker ones will make it look rough and blurry. Now I can use this output map to dial in the exact amount of sharpness and blurriness. So I'm going to enable color map, select the first point and increase its Y value to around 0.675. And this will make the dark values of the texture much brighter, and therefore we'll get a sharper specular reflections in those areas. And then select the second point and decrease its values from 1 to around 0.9, 0.92. And this will make the brighter values darker, and therefore the sharpest parts of the specular reflections will become less sharp. And again, this depends on the particular reference that you are looking at. If it's a matte plastic, you need to darken the image and get rougher and blurrier reflections, and vice versa. Or if the surface you are replicating is new and does not have tons of scratches or fingerprints or smudges, you can decrease the contrast of the texture assigned to the specular glossiness by simply making the first and the second point have closer Y values. Another thing that you can do to make your shader look more realistic is to make the perpendicular faces a bit sharper compared to the parallel faces to the viewing direction. If we were using a Viri material, we could have used the coat section there. Unfortunately, Fast SSS2 does not have a coat layer at the time being, so we might need to get our hands a bit dirty and do it manually. So what I'm going to do is to use a Falloff map, and this will give us white or 1 values for the perpendicular faces and black or 0 for the parallel faces. Then we can simply add that map over our original specular glossiness texture to get the final specular glossiness map. First, let's add an Osl Falloff map from the Osl utility maps. Or you can use 3ds Max's native Falloff map. The end result is the same, just the parameters are a bit different. I'm going to temporarily connect it to the specular glossiness texture input. So if I decrease this power value to something like 0.2, you notice the perpendicular faces are much sharper and the parallel faces, the viewing direction, are much blurrier or rougher. If I look at the map in isolation, you notice why this is happening. The parallel faces are shaded darker, therefore will be rougher, and the perpendicular faces are shaded brighter, therefore sharper. Now we can simply use a composite node and add this falloff on top of our original texture. So add a composite node. We need 2 layers here. The original texture will be layer 1 and the Falloff map will be layer 2. And we'll be using this composite map as our glossiness texture instead. I'm just going to change the blending mode for the second layer to addition. And now you can see how these perpendicular faces become much sharper. And now we can dial in how much of that we want using this opacity amount for the second layer. I'm going to probably set the power amount for the Falloff map to around 2 and decrease the opacity to around 30%. And this will add another level of realism to the overall shader. The next thing to consider is to work on the bump mapping. For most surfaces, you need an overall unevenness that can be achieved with a simple noise and then more high frequency details, which you can just reuse the specular glossiness map. So add a Viri normal node. Use the original glossiness texture as the bump map input. And then connect the Viri normal node to the bump input of the Fast SSS2 shader. And now we need to dial in the exact bump amount that is needed. We can enable this real zoom feature in the IPR and zoom in a tad to see the results a bit better. Right now the bump amount is too much. Let's decrease it to 0.1. Still way too much for a surface like plastic. Let's try 0.01. It's still too much. And let's try 0.003. Okay, this looks good. We don't want to exaggerate anything. Subtle and little is always better. So that's the high frequency detail. Now we can get out of the real zoom. And let's quickly add that general unevenness to the surface using a simple noise map. You know, most of the materials and surfaces surrounding us in real life are not made perfectly. It's not going to be perfectly smooth. There is some sort of waviness to them. And if you take a look at any reflective surface around you, you can see that overall waviness and unevenness to them. We can use a composite node with two layers. The first layer would be the glossiness texture, and the second layer will be the noise node, and then that composite node will be used as the bump map input for the V-Ray normal node. Or we can use V-Ray bump material like we learned in the bump mapping video a few lessons back. But the simplest way is to use this existing V-Ray normal node and simply connect a noise map as the normal map input. Let's see if that is possible or not. So let's add a noise map and decrease its size to around 5. And then connect the noise map to the normal map input. The result is odd. We can see the noise pattern, but it looks incorrect, and that is because the normal map input needs a normal texture, not a grayscale texture. Is there a way to convert the grayscale noise map or any other grayscale map to a normal map on the fly? Yeah, it's fairly possible through a V-Ray bump to normal node. So let's add one. Connect the noise map as the bump input. And now connect the V-Ray bump to normal as the normal map input. Now it looks correct. Now that's the type of unevenness that I'm talking about, but we want to be subtle here. So let's set the normal strength to around 0.3. Now let's see what we get. Now, the good thing is that this whole shader is being controlled with this one map that is connected to both the specular roughness or the specular glossiness and bump input. If we load another texture, you would get an entirely different look. Just load another black and white map and see what happens. Now, let's quickly turn this into a yellow plastic shader. I'm gonna duplicate the whole shader and assign the new one by simply shift dragging them. And now we just need to change the color in the V-Ray color node to any other color that we want. Let's go for a yellow color with the RGB values of 248, 133, and 0. And that's our yellow plastic shader. Let me show you the final renders with both the red and the yellow plastic shaders. Now let's pick up the pace a bit and go for a wood parquet shader. This time we'll use V-Ray material as we don't need subsurface scattering for wood. So create a new V-Ray material and assign it. Add a V-Ray bitmap node and load this parquet.png texture. As this is the diffuse color texture and we are in ACES, set the RGB color space to sRGB. I'm gonna also set its tiling to around 0.75 so it sits larger on the shader ball. I'd like to use the roughness mode when using very material, so let's change the mode to roughness. Set the reflection color to white. And IR can remain at its default state as we discussed earlier. Now let's go for the reflection roughness immediately. I'm going to load this parquet underscore roughness texture. Change the color space to raw and tiling to 0.75 like our diffuse color texture. I'm going to quickly invert the texture as this texture was created for glossiness workflow. If I view the image and zoom in, you notice the narrow edges between the boards are black, which if used as a roughness map will end up giving us sharp reflections in those areas. And the wood grains are also darker, which again make the surface sharper if used as the roughness texture. By inverting it, the map will be proper to be used as a roughness map. You can do that in the output rollout of the texture. And another suggestion to Chaos Group, just use the roughness map like any other modern workflow and ditch the glossiness value. Just replace it completely and be done with it. We can connect it directly to the reflection roughness input, or like the plastic shader, let's put it through an output map for further adjustments. So connect the roughness texture to an output map. And connect the output map to the reflection roughness input. I'm just gonna make the dark values a bit brighter by increasing the first point Y value to around 0.1, and that would make the sharp parts less sharp. Now connect it to the reflection roughness input. Let's quickly add some bump mapping as well. I'm gonna copy the specular roughness map and load this parquet underscore bump texture. Just make sure it's not inverted, because if we take a look at the texture, we know for bump maps the black pixels cause indents, and this map looks right at its raw state. And connect it to the bump map input of a very normal map node. And connect that to the bump map input of the very material. And let's decrease the bump amount to around 0.25. Now let's add that overall waviness like the plastic shader. I'm just gonna steal the noise and the bump to normal from one of the plastic shaders. And connect the bump to normal to the normal input of the V-Ray normal node. And set the normal amount to 0.25, 0.3 like the plastic shader. Thankfully, V-Ray material has a coat component, so we don't need to use any trickery to get that sharper perpendicular reflections. Just set the coat amount to 0.3, coat roughness to 0.1, as I don't want them to be very sharp in this case, and coat IOR to around 1.25, so the coat will be limited to only the incidence angles, as we discussed in the coat video a few lessons back. So that is our simple parquet shader. Let me just stop the IPR and show you the final render for this shader here. Now let's go for a quick concrete shader. I'm going to add a new Vary material and assign it. Use roughness instead of glossiness. I'm going to add a new Vary bitmap node and load this concrete underscore 01 underscore D. And use it as the diffuse map. For the reflection roughness map, connect the same map first to an output map. For the same reason that we inverted the parquet roughness texture, we need to invert this map as well. And let's use it as the reflection roughness map. And for the bump map, connect the original diffuse map to the bump map input of a Vary normal map node. And set the bump amount to something like 0.3. And that's a simple concrete shader. I didn't use the noise map here for that overall unevenness or waviness. You can do that as well, but here the surface is rough and that waviness is generally visible on more, reflective, sharper surfaces. And here is our final concrete render. And finally, let's go for a metal shader. So create a new Vary material and assign it. Let's use the gold preset to get us started. I'm just gonna make the color a bit less saturated with the RGB values of 243, 207, and 121. For the roughness, let's add a Vary bitmap node and load this bw underscore metal underscore 02. Temporarily, let's connect it directly to the reflection roughness to see how it looks. And I'm gonna set its RGB color space to raw as it is a data input and we are in ACES. Increase the tiling to 1.5 and 1.5. And I'm gonna set the W angle to 125 to give the scratches a bit of diagonal direction. As always, let's use an output map before connecting the texture to the reflection roughness input. Enable color map. Set the Y value for the first point to 0.05 and for the second point to 0.4. I'm just going to change the point types to Bezier corners and add a bit of bulge to make the values of the map less contrasty. By now you should know why we actually decreased the Y values. For example, for the second point, we changed it from 1 to 4. Therefore, the brighter values of the map got quite darker. And when used as the roughness map or reflection roughness map, they should end up making the surface less rough or much sharper. Now for the bump map, connect the original roughness texture to the bump input of a Vary normal node. And connect the normal node to the bump input of the Vary material. And let's decrease the bump amount to 0.02. Finally, we can steal the unevenness combo from the plastic or the wood shader. And connect it to the normal map input of the normal node and set the normal amount to around 0.25. Let me stop the IPR and show you the final render. Just make sure the noiser is disabled so we can see all the details for this render. It's a nice shader. So that's how you approach creating different shaders in V-Ray in their simplest form. Obviously, these can get much more complex than this. Now you have a good foundation to build upon. It's a very simple approach. Specular or reflection roughness is the key to everything, and you build around it. So in this lesson, we'll learn how to create shaders like plastic, parquet, concrete, and metals. See you in the next video. Make sure to visit our website mographplus.com or our Gumroad page at gumroad.com/mographplus and check out our premium CGI and rendering courses for Cinema 4D, 3ds Max, Maya, Arnold, Corona, V-Ray, Redshift, Octane, and so on. See you in the next video.